A bomber diving at an angle of 53 degrees with the vertical. Oh, that's weird. Releases a bomb at an altitude of 730 meters. The bomb hits the ground 5 seconds after being released. What is the velocity of the bomber? So, what do I need to draw in my picture? Sure, I'll draw a plane. That's my plane. Yeah. Here's my axes. Vertical, horizontal, and the projectile will go that way. And it says 53 degrees from vertical. So what's the problem with 53 degrees from vertical? What are we normally guiding off of? What is our sine and cosine have been guiding off of? The x-axis, right? We've been working with the x-axis to make sure that sine goes up and down and cosine goes side to side. So we need to flip-flop our terminology of sine and cosine around as we work. But did they give us a speed? No, in fact, it's our missing piece. We're looking for the velocity. So we've got a bomber diving at an angle of 53 degrees. We've been given a time, t, equals 5 seconds, and an altitude of 730 meters. What do you want to put in front of that? So x equals a negative 730. Not just that, but we know it's launched with the plane's movement speed. That the acceleration is equal to negative 9.8. I feel like we have a lot of vertical information. So why don't I find my vertical initial velocity? This is velocity initial in the vertical direction or in the y direction, right? Maybe you want to change that to a y. If we can find this, we can start answering the actual velocity question that they're giving us. This is a diagonal velocity that I'm looking for. Velocity initial. I'm looking for my vertical component first. Vertical initial y component. How do you find that vertical initial y component? What equation would you use? VI y times t plus 1/2 a t squared. Does that equation work for us? Yeah. In fact, it's kind of convenient. We've got negative 730 equals what we're looking for, VIY times 5 plus 1/2 negative 9.8 times 5 squared. This is negative. We'll move that over. I don't know what that term is. 730. I don't even care what that term is. Negative 730 minus 0.5 times 9.8 times... Wait, I'm going to add. Why am I going to add? Double negative, right? Yeah, this is negative. I could have put a negative in front of the 9.8. 5 times 5. Okay. I have VIY, 5 VIYs equals 607.5. So divide that by 5, right? I get, oh good, 121.5. VIY equals, so this is 121.5 in the vertical direction, meters per second. Is that the diagonal speed that I'm looking for? No. So you could build a whole triangle around this and say that this is just the vertical. I have 53 right here, and I have 121.5. So cosine 53 equals 121.5 over the hypotenuse or the diagonal. So really it's, let me write that down. 121.5 divided by h equals cosine, right, adjacent, 53. So if I'm looking for h equals 121.5 divided by cosine 53. Hopefully I rearranged that triangle correctly. Because this is my 4th period of doing this, so yeah, I better. And I should get a number that's bigger because my hypotenuse is my longest leg of this triangle, right? And so 121.5 divided by, I need to divide it by 53. 202-ish? So my speed initial is equal to 202 meters per second. Hey guys, this is not complete. What did they ask me for? The velocity. Is that a scalar or a vector word? Vector. So I need to report back the angle. What angle are you going to report back, though? 53. They told us at the beginning. So it's not crazy. At 53 degrees with vertical. And I'm going to phrase it exactly the way the question phrased it, because if I'm reporting back exactly the way the question phrased it, I'm not going to include north, south, east, west, because we don't know any of that. We only know that it's 53 degrees from the vertical line. And vertical is up and down, not north, south, east, and west, okay? With vertical, right? How far did the bomber travel horizontally during its flight? Triangle information. We need this speed. We need the Vx. We have the Vy. We have the V initial. V initial was 202. That's a rounded number. We have the Y direction. That's 121.5. What's the easiest way to find Vx for you? Pythagorean theorem. That's true. What is the least rounded way of finding this? Tangent 53 equals over adjacent. We have the adjacent, 121.5, and we're looking for our x. They will give you the same thing. I'm just saying that this top thing, this tangent thing, is not rounded. (121.5 squared plus b squared equals 202 squared. That's rounded. Right? And so you'd have to use like 201.889 if you wanted to be more accurate with this. But they should be equivalent. So either way you go about it, this and this, they're the same. What do you get? 161 meters per second. Wait, that's not done. That's not how far it goes. That's how fast it's going that way. We know also that it's 5 seconds, so why don't we just say it's going that fast for 5 seconds? So multiply it times 5 and you get... I got 704 when I didn't round it. When you round it, I think you get 710. Okay? So 710 is close enough.
Yeah, we got 806.
806 and then it's 810. 810 when you've rounded it. I'm off by 100. I just misremembered. I was just pulling it out of my memory, so you're probably right. You said 806?
Yeah.
All right. I'll see y'all later.